All right, so it says we have this graph. This is a SAT question, by the way. So we have a graph, and we're trying to figure out, this is the first question on the bell work. What does the C-intercept represent, which would be this point? Now keep in mind that C in this example represents the total cost. So I want you to take a 60 seconds looking at your choices, A, B, C, and D. I'll read them aloud. You pick which one you think would be the correct answer. So A says it's the initial cost of renting a boat. B says the total number of boats rented. C says the total number of hours the boat is rented. D, the increase in cost to rent the boat for each additional hour. So, who thinks it's A? B? C? D? That's what they said first period too. That's what they said. Okay, but the answer is A. And let's talk about why it's A. First of all, you want to pick, if it doesn't have the word cost in it, we know it's not that. So automatically, I'm glad nobody picked B or C. What D would represent is the slope. And it didn't ask you for the slope. It asked you for the y-intercept, which is A. So if you think about it, this is where this line starts right here. And another word for start is initial. So it's the beginning cost to rent a boat. So no matter how many hours you spend on the boat, you're going to have to start by paying $5. That's the starting cost. And then it goes up depending on how long you're in the boat. But you're not going to get in that boat for less than $5. All right, so now let's go to our blue packet. Let's go to page 13. In our blue packet, page 13. And we're talking about complex numbers. So what we did was we took chapter 1 and we split it in half, which is why we're still in that packet. So you took your test over the first half, and now we're going to do the second half. And I'll have to remind you, I don't know when the test is, but we have our second test coming up. It's probably a couple of weeks. Okay. So not all graphs will cross the x-axis. But what that means is it has that doesn't mean it doesn't have a solution. That means that the solution is not real, or it's two imaginary solutions. So we have the graph. Nakeem, can you put that away? I think a S1 is brewing. It's about that time, y'all. My niceness is worn off. It's about that time. All right, so the graph y equals x squared plus 4 is shown to the right. And do you notice that this graph does not touch the x-axis? The x-axis is all the way down here. So that means that the solutions are imaginary. So when something is imaginary, we call it I. And we get that when you try to take the square root of a negative. That's when it's I. So what you need to know, two things. You need to know that I is equal to the square root of -1, which means that I squared is -1. 13, page 13. Any questions about this page? So we're just going to practice simplifying some square roots and then looking at the graph and graphing things with imaginary solutions. Now, can everybody pick up your calculator and type in square root of negative, this one right there, 80. Type in square root of -1 in your calculator.
Where's the button?
So you have to hit the second function button, which on the yellow calculators is green. And then you want to hit where it says x squared. And you should get a square root symbol. So when you type that in and you put in a negative, does it tell you domain error? That's because it's imaginary. Now, some calculators will say imaginary or not real, okay? So, let's talk about perfect squares. A perfect square is what you get when you multiply a number against itself. 1 times 1 is 1. What's 2 times 2? 4. What's 3 times 3? What's 3 times 3? 6. 9. This is going to take a long time if y'all don't participate. What's 4 times 4?
16.
And what's 5 times 5?
25.
So these are called perfect squares. Because if you were to make a box, like I can make a box, and you don't have to draw it, but if I make a box where there are 3 squares going down and 3 squares going across, it would be a perfect square. It wouldn't be a rectangle because the sides are equal. We know that in a square, if it's a square, all sides are equal. That's why we call it a perfect square. For 2 times 2, if I make a square, that would still be a square because I have 2 going down and 2 going across. And the total number of boxes I have here is 4, which is why 4 is a perfect square. The total number of boxes I have here is 9, which is why 9 is a perfect square, etc. Okay? If you look in the front of the room, I have those numbers in pink are perfect squares. I also wrote these numbers on the back. I didn't write 1 because 1 goes into everything. So we don't really talk about 1 being a perfect square. All right, so the square root of 4, what number do I have to multiply against itself to get 4? That would be 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. So when we simplify a square root, well, let's talk about simplifying a square root in general. I think most of you all would make a cake, which I'm going to do that. Remember, you just keep dividing it by prime numbers until you get to the birthday candle at the top, which is a 1. I'm looking for a pair, so I have a pair of 2s, which is why that 2 can come out. It's free because it has a friend. This 2 does not, so it has to stay. So my answer would be 2 root 2. Another way to do that, though, is to take the square root of 8 and see which one of these numbers can divide into 8. Does everybody agree that 4 will divide into 8? 4 times what is 8? 2. So I'm going to break this apart to 4 times 2. And then this is going to change to a 2, and this has to stay. 2 different ways to get the same answer. Now, this is the method I prefer. But on the test, you do it the way you know you're going to get it right. If there is a negative underneath the square root, so now we're going to do some practice for your homework. The first thing you're going to do is remove it. So I want you to separate the negative from the 2 because they're really separate. Anytime you see a negative, it's a -1. Now, going back to what we started off saying here, the square root of -1 is equal to what? I. So I'm going to change the square root of -1 to I. And then this stays under the radical, and it's just going to go behind the I. And that's your answer. That's it. Number 2, first thing you want to do is separate out the negative. And then you have the 25. All right, the square root of -1. Again, I. What's the square root of 25? 25 is one of the numbers I have listed. 5. Now, whenever it's a number, we generally put that in front. Now, I would not mark it wrong if you put it behind it, but normally we put the variable behind the number. So this would be your answer. Let's look at number 3. Separate. All right, take a moment, see if you can figure out what I'm looking for, what the answer would be. Excuse me. Who said 4i? That would be right. The square root of -1 is I. And the square root of 16 is 4. All right, but what about if it's not a perfect square, like number 4? We just have to build a cake. So, or look for the perfect square. So I'm going to take out the -1, and then I have the 12. So I want you to look at the numbers that you see listed. Which one of these numbers do you think I can divide, not subtract, divide into 12? Show me with your fingers what number you think it is. It can divide into 12. If you're not sure, pick up your calculator. Start with the first number less than 12. Start with 9. Pick up your calculator, take 12 divided by 9. Did you get a whole number or a decimal? Decimal. All right, now do 12 divided by 4. Did you get a whole number or a decimal? So what did you get when you divided 12 by 4? So that means that I can break this apart to a 4 and a 3. I'm going to show you the cake method also. Because again, you pick the method that you're comfortable with. So this will become I. The square root of 4 is 2. I'm going to put that in the front. This cannot be simplified further, so that would go in the back. That would be the answer I'm looking for. All right, if you didn't want to do it that way, and you wanted to make a cake, you would just take that 12, you would divide it by 2 until you can't anymore. And the same thing would happen. See how we have our pair? That's represents that 2. And then the 3 represents that 3. So who likes to build the cake? I don't care. I just want you all to get it right. I'll talk about the first test in a minute. I was a little surprised, a little bit surprised by the test scores. Not gonna lie. So we'll talk about that in a second. Okay, so now let's look at 8, 9, 10, and 11, and then we'll be finished, and you can use the rest of the time to work on homework 3. So whenever we're going to solve, that's where we introduce the plus minus. So what we're going to do, first of all, A is 1. Does that mean that this is going to be a smile or a frown? A is positive, so what does that mean it's going to do? It's going to be a smile. So I'm just going to draw this right here as a reminder, okay? All right, so we have 0 equals x squared plus 1. First step, subtract 1 from both sides. And then we're going to take the square root. And what did we say the square root of -1 was? I. So because I'm solving it, I want you to put the plus minus though. So whenever you have an I, that means, because that's not real, it will not touch the x-axis. Does not touch x-axis. Because it's I. So what I'm going to do is draw a smile that does not go down far enough to touch X. So as long as it's a smile, that's all that matters. All right, let's look at number 9. 0 equals x squared plus 9. Subtract the 9. Take the square root. So now I got to separate it because there is a negative. You have to take the negative out. So that negative 9 really represents negative 1 times 9. So the square root of negative 1 is I. And the square root of 9 is what? 3. Put the plus or minus because we're solving it. That's my solutions, but it's imaginary. So I'm just going to draw us this. It can look the same because it's still a smile. It just does not come down far enough to touch X. It makes its U-turn before it touches the X-axis. Any questions? All right, let's look at number 10. So we have 0 equals x squared plus 16. Go ahead, take a couple minutes, try to do that one on your own. All right, so we're going to start by subtracting 16. And then we're going to take the square root. So this will be negative 1 times 16 equals x. So you should get that x equals plus or minus 4i. Who had that for their answers? Again, you're just going to draw a smile that doesn't come down far enough. Now, 11 is the first one that a is negative. So this one is going to be a frown. So let's go ahead and solve that. 0 equals negative x squared minus 49. So we're going to start by adding 49. So now to get rid of the negative, I have to divide. And then lastly, I'm going to take the square root. So I'm going to separate this down to negative 1 times 49, which would be plus or minus 7i. But this time I have to draw a frown. But it doesn't go up high enough. It makes a U-turn before it touches the x-axis.